coming up on Built to Last.
We'll talk with Energy Star expert Sam Rashkin about the progress of our home and work to tighten our envelope with energy-efficient exterior and windows.
Now let's get to work.
Support for Built to Last is provided by
Unico Incorporated, manufacturers of the small duct high velocity HVAC Unico system. Unico is dedicated to the environment and has been serving residential and commercial customers around the corner and around the globe for more than 25 years.
Great Northern Lumber, providing green construction materials from skyscrapers to residential remodel. Proud to serve you for the last 27 years and into the future in the lumber industry.
Bosch, power tools for professionals. Proud sponsor of The Green Home. Florida Tile. Expect more. SPI Incorporated, protective coatings, proven performance, and real-world solutions for 24 years. Additional funding is provided by these firms.
As you can see, our carpenters have done a great job framing our home and installing the sheathing. There's going to be a lot of activity happening now, so let's check it out.
What this is that's picking up the framing of the porch. Here.
What is a post?
That's a post in there,
Okay.
yes.
And
Earlier in the day, our green building expert Sam Rashkin toured our home with Bruce and Laureen to check up on the progress of the home. Now it's time for Sam to tell me his thoughts on our project.
Well, Sam, I know it's been a while since you've been here and you've had a chance to look around the house. I'm excited to get your thoughts.
yes, there's a lot of progress and a lot to talk about.
Well, let's go.
Okay. So Amy, let's start in the basement.
Sounds good. It looks nice and cool in there, too. Okay, Sam, here we are in the basement. What are your thoughts?
Well, Amy, if you may remember, I think last time we talked about how in a high-performance home, a basement actually performs almost just like the upstairs space.
Right.
So it's like getting bonus space almost for free. Let's talk about some of the innovations and technologies that are down here that make that possible.
Great.
I think it all begins with these outside walls, which unlike in a typical house, they would be concrete. This is an insulated concrete block technology, which means the insulation's on the outside and the concrete's poured in the inside. Kind of the inverse of a normal concrete block. And what's amazing about this technology is it creates a complete blanket around your basement wall that makes it much, much more comfortable. The walls stay much, much warmer in the winter. So you can be down this space and feel a lot better. But that's just the beginning. On the walls that are on the outside, you'll notice that one, they're like normal construction and they have lots of windows, so a lot of daylight to make this space feel really good. But those walls also are 6 inches thick. Most framed walls are 4 inches, so you're getting like 50% more insulation. On top of that, those walls are being wrapped with 1 inches of rigid insulated board. And that's going to make a complete blanket on those walls as well. So this basement's going to feel really comfortable in the summer and the winter. So
nice.
Really good technology. And lastly, in the old days when we built with wood construction, we'd have solid wood framing throughout the ceiling. And if you look here, you see these open trusses. And what's really good about those open trusses is those spaces between the truss members is useful for running wiring, plumbing, and ducts, so we have more useful space below. So this basement in a high-performance home really feels just like the space above with all these new technologies.
How nice. It sounds wonderful, and I wish I had all these features in my home. Well, let's go. I know. Oh, well. Let's go upstairs then and see what's up there.
Sounds great.
Okay. Well, Sam, we're on the main level. There must be a lot of insights to share. I'd love to hear your thoughts.
Yes, just like in the basement, I think there's a lot going upstairs here we should talk about as well. And some of it's similar, some of it's different. Let's talk about what's similar first, which is, again, we have 6-inch wall framing running around the entire outside of the walls. And like in the basement, that framing is going to be covered with 1-inch rigid insulation board. Now, let me explain why that's so important upstairs when I didn't downstairs. Look at all the framing on these walls. Does it look like a lot of wood to you?
It does.
Yeah, even though this is advanced framing with maybe 20% less wood than in a conventional frame wall, leaving more space for insulation. What we find is there's still a lot of wood in the walls. And that's significant because we're losing heat 5-6 times faster through wood than through the insulated wall. And so it's good that we have more depth, 6 inches for insulation and less wood, but we still have a lot of thermal highways for heat to escape, and in the summer for heat to come in. So that rigid insulation board is really important on the outside. It's like putting a complete blanket around the outside, and it creates an amazing difference inside. What it effectively does is keep the surface temperature on these walls warmer in winter, cooler in summer. And that's so significant because there's 40% more impact surface temperatures on our comfort than the ambient temperatures.
Is that right?
Yeah, so we really have to realize how important that detail is. I think in high performance homes, anytime you can wrap the insulation around the outside, very, very significant. All this is going to make the upstairs just like the downstairs. Really comfortable, really efficient. But I want to mention one more detail. This is a very special design. You notice how high ceilings and vaulted ceilings everywhere?
Well, it is, and you see these a lot in homes. And, you know, I kind of wonder, is there a loss of energy with the higher ceilings?
Yeah, I thought you might ask that. And a lot of people do worry about that. When I have 10-foot ceilings or vaulted ceilings, what's going to really happen to my energy needs, my utility bills? It's important to recognize it does add some to the utility bills, but not that much. When you do the other high-performance details we talk about, the rigid insulation, the thicker insulation, the better air sealing details, it makes the house so much more efficient that we can actually have a little more volume, higher ceilings, and not have any significant impact on the utility bill. There is an impact, but not that significant. So we can feel like really good about having the design choices we want and a high-performance home.
Great, thanks for that. I love the look of this, and I really appreciate you coming out. Your insights are so helpful and informative, and I can't wait to have you back.
That will be great.
Now it's time to tighten our home's thermal envelope. The rigid insulation that Sam Rashkin discussed with us is being delivered, and our carpenters are ready to hang the material.
We've pretty much completed our exterior sheathing of the home. We have our wall sheathing in place and roof sheathing. So the next steps we're going to take is we're going to be adding 1 layer of rigid insulation to the exterior of the house. And if I had a sample here, oh, great, we've got a sample. And thank you. What we're going to be doing is we're going to be applying this over the system. And what this will do, it'll prevent thermal bridging to the exterior of the home. And with our zip wall system, this becomes our air barrier, but what we're doing is we're taking this a step further. We moved our subframing in about 1 inch, so we're not taking space away from the cavity of the home for the brick. And so what this will do is we'll put this on there, and then on top of that, we're going to be adding a layer of water barrier. So any water that weeps through the brick or moisture that gets in from the exterior will be channeled down through the flashing at the subsill of the house. So the house will be watertight, but what we're doing is we're getting a great envelope to get a better R rating of the home where their exterior will be completely sealed and weathertight. So it's a good way to do it, it's a good system, and fortunately we have the capabilities of incorporating it into our home.
Since the material is lightweight, it doesn't take long for our carpenters to install the rigid insulation. With the help of a lift, it only takes 2 carpenters to size and place the rigid insulation before adding the water barrier. The water barrier is rolled out and fastened with nails before the seams are covered with tape. With the insulation and wrap in place, we're ready to install our windows. Our home will be utilizing 33 windows and 3 sets of sliding glass doors, so proper installation will play a big role in the house's feel and energy use.
As we've been going through this process, one of the most important things of any home is that exterior envelope. Windows are a very key component of that. With the windows that we're using here, they're not a traditional double pane. We're actually using a triple pane, which is a little bit unusual for most everyday homes that are being built nowadays. And right now we're looking at about a 0.19 on the U factor. Now what the U factor means is how much heat the window actually transfers back and forth. Then there's this thing called the SHGC. You'll see it on your label. That stands for your solar heat gain coefficient. And this is another way of explaining how much that the heat comes into the home. For this project, we're at about 0.19 for the U factor, whereas something more traditional would be in like the 0.32 or 0.30 range. And the organization that actually does these ratings for the windows is called the National Fenestration Rating Council. So it's not like we come out here and we decide the window is XYZ U factor. There's actually a third-party organization that tests the windows as a complete unit and then tells us what the U factor is.
Now we know that there are ratings to look for as we purchase windows, but there is still much to learn about how windows perform. Luckily, we have the chance to speak with window expert John Saccone about windows' hidden technologies.
What makes a vinyl window different than a wood window is we actually create chambers inside the frame of the window which traps air. And as you know, air is what causes energy efficiency in homes.
Because it acts as insulation, basically, when it's trapped in these channels?
Exactly. Like fiberglass insulation, it's not necessarily the fiberglass that causes the insulation, it's actually the air trapped in the fibers.
Very good.
Pretty cool stuff, right? Same thing with our vinyl window here. We've trapped air inside the chambers and we create this insulation factor. The other thing we want to consider is the glass pack. So this is a triple pane insulated glass pack inside this window.
Yeah, I see there's 3. I've never seen 3 before.
Exactly. This is becoming more and more popular. In the old days when energy wasn't as costly, we used a single pane. And also we didn't have the technology to do what we can do today. This insulated pack right here consists of 3 panes of glass, and I like to say the more panes in your window, less pain in your wallet. We also create 2 air cavities with the triple panes of glass, and we can do some things to those air cavities to make them even more efficient.
Like what?
Well, we can actually do low E inside the glass pack on 1 or 2 surfaces.
Okay, low E, that's a term I've heard. What does that stand for?
Well, the E actually stands for emissivity, but it's not anything we want to talk about here because it'll bore our viewers to death. So can I tell you what it does?
Please.
Okay, low E actually prohibits the rays from coming through the glass. The rays that warm your house in the summertime can also fade your carpets and your drapes.
Oh yes.
So low E, it's pretty smart stuff. It is actually a microscopic metal oxide film or additive to the glass. And it, as I said, it's pretty smart stuff. Summertime, sun is high in the sky, and the rays are very steep, so it won't come through the glass. Wintertime, sun is a little bit lower, it does come through the glass. And unfortunately, you can't really see it. You can't tell it's there. But they will label the window so you know it does have low E.
Look for low E.
Right.
Okay.
The other thing we can do to the cavities, we can add gas to it.
Ah, what kind of gas?
What kind of gas? I knew you were going to ask me that. Actually, the most common gas is argon. Now, let me tell you what gas does. Gas is really a denser, inert air, if you will. So it prohibits the transfer of heat and cold from side to side. Sort of does what low E does, but it does it in a different fashion. Argon, like I said, is most common. We can also use krypton. That's the stuff that killed Superman.
Yeah, I was going to say.
Really, it's not the stuff that killed Superman. In fact, it wouldn't hurt you or I. It's odorless, it's tasteless, and it's non-toxic. So people shouldn't be afraid about putting gas inside the cavity. If a pane of glass breaks, it's not going to poison anybody in the home.
Right. These are just basic elements from the periodic chart.
Exactly.
Okay.
You did your science in
I
school.
did.
Yes, you did. Final thing I want to talk to you about is installation. You know, with any good product, especially an energy efficient product like windows, if you don't install it properly, it's not going to do any good. So the installer's got to follow the manufacturer's recommendations. Otherwise, air leaking into the home, none of this is any good anymore. Does that make sense?
It does. Oh, this has been so informative, and I'm sure that whoever ends up with this home will enjoy the windows for not only their beauty, but also for the technology behind it. John pointed out how constant improvements in window technology help us save energy and money. All those improvements would be in vain, though, if we didn't install them properly. So let's take a closer look at proper window installation.
Homes being built today really need to be able to keep water and air from getting into the rough opening. With homes being built the way they are now, so tight, if we have a difference of pressure inside the house compared to outside, we're drawing that air and moisture in. So we really have to seal off that rough opening the best we can. If we have air coming through there, it's drawing moisture in, and that's causing problems. If water gets in, it causes mold, rot. You have litigation possibilities. If a window does not open and close properly, the weather stripping is not meeting all the way around, you're going to have air coming in and water, and you'll have sound from the outside as well. So sealing it off is very important. One thing we're having them do today, as you can see, the wrap, and there's many different ways to do this, but the house wrap was brought in around the corner, trimmed off on the jack stud, but since that can allow a cavity for air between the weather-resistive barrier and the sheathing for it to be drawn into the house, we tape this off vertically to eliminate any possibility of air or water traveling around the corners. And you can imagine in a house this size with all these windows, there's a lot of square footage and lineal footage of opening for that to be drawn in. We want to, when that window's installed, to leave an avenue for water to escape. So they'll build the sill pan, which they've done, flash, go on top of that sill pan, so again, that weatherboard effect, the shingle effect, water running downhill, can gather into that pan and drain to the exterior. The next step would be, when they install the window, they're going to apply a sealant to the backside of the nailing flange, and that'll create a gasket-like effect to the house. You can imagine running a bead of sealant on the sides and top, pushing it up against the weather-resistive barrier. It'll actually create a gasket, so no air and water can get in. However, at the bottom, in case water gets into the opening, we're going to leave a couple gaps in that sealant so water can escape.
Centered so you can nail both bottoms.
The carpenters have done a wonderful job of installing the windows and glass doors to the manufacturer's specifications. They finished just in time as our exterior trim is delivered and ready for installation.
So I'm here with Brian Shores. We're looking at the trim, which has mostly been installed on our home. Brian, can you tell us a little bit about the trim?
Yes, this is James Hardy's fiber cement trim. It comes in 12-foot lengths, and it's comprised of Portland cement, sand, cellulose fibers, and water. It's a very green product. You actually can get some LEED points with this product as far as the renewable, easily available products they have inside of it. It comes in 12-foot lengths, like I said, and installs with any of the typical tools that a carpenter would use.
Well, it looks just beautiful, and I noticed that it's very solid. It's not flexible like aluminum or vinyl. So what special skills are needed to install this?
Well, you definitely want to have a quality craftsman install the product, but again, I said it's going to install like a wood, so a carpenter who's been trained with the right abilities will be able to install this fine. It's going to be able to nail it on in the same manner as well.
Well, it looks absolutely gorgeous. I can't wait to see everything all put together with a brick on the exterior of the home. You'll have to come back and check it out.
Okay, I'll definitely come back and see.
Okay, thank you so much.
Sometimes people overlook what a great trim can add to a house. But on our home, the work put into this trim will definitely be noticed and admired. Now that our trim is complete, it's time to get to the top. And by that, I mean our roof.
We're getting ready to start our roofing. Some of the things we had to have in place in order to get to that point is we had to get our exterior fascia soffits in place. We're a composite cement material, so we got to get that on first so we can run our drip line and everything over those to kind of protect them from the weather. So they went through, they spent a couple days, they got the fascia on soffits, and so we're ready to do the roofing.
How we start our project is we get up on the roof. All our guys will be equipped with safety harnesses and lanyards. After that, start putting our underlayments down. So our underlayments consist of our ice and water shield barrier. We ran that 6 feet up. After that, we went back with our underlayment.
The underlayment we have on the roof, it's a synthetic fiber material instead of felt paper. It's something that's more durable, a little more resistant to the weather, for exposure. It doesn't wrinkle as much as felt paper would. It's a stronger component, it's lightweight. It's a new product to hit the market, and we're excited to get it on this house.
And then the third step is then to start installing our shingles.
The shingles on this project are Energy Star rated shingles. The neat part about this product is threefold. Number one is that it has a reflectivity that is measured by the government for the Energy Star rating, which is at least a 0.25 SR value. Now that translates into a solar reflective index of 29% of the UV light is actually reflected off of this roof so that it's not absorbed into the shingle, which then would absorb heat into the roof. And what it is basically a white coated granule on the underneath, or the first base coat of the granule is white. And the pigment or colorant that goes over the top of that granule basically allows UV light in, but then it's reflected out because of the white. And that gives it the characteristic of the Energy Star rating and the solar reflective value. But the real key component for any of the neighbors or any of the neighborhoods that this product is utilized in is that the shingle looks identical color-wise to some of the other roofs that are in the area.
After we put in our roof flashings, which consist of baby tins, roof-to-wall flashing, brick counter flashings, those will kind of come at the end. As the brick is completed, we install our ridge vent. When we install that, we put on a 4-foot piece of rigid plastic, and that lets air out of the attic. The soffit vents on the overhang of the house let air into the attic, which is then pushed up to the ridge vent at the peak, and air circulates out. With this particular product, it's a shingle over product, so we install a ridge cap to finish things off and give it that finished look so it matches the rest of the house. You want airflow through the attic so that it blows cool air through the attic and helps cool it down in the summertime, but also in the wintertime you want to make sure that any warm, moist air that pushes its way into the attic space gets blown out as well. So you want a continual airflow through the attic so it's properly ventilated. So ventilation is key for a roof. It's important to work with the manufacturer and to know their specifications, because at the end of the day, it's the shingle manufacturer who warranties the product. Each roofer has his own labor warranty, but it's the shingle manufacturer that will honor the warranty if there's a material defect.
It is a very important component of any sort of homeowner who is going to be doing any sort of roofing or siding or any sort of contract work, that they do utilize the credentialed contractor basis from the different manufacturers. And this is very important because if they don't install it properly per our installation guidelines, there could become a potential issue with the warranty that us as manufacturers are the ones who carry.
Our carpenters have done a great job so far. Join us next time as we finish up our exterior with brick and stone and install our water management system. See you then.
Visit the Built to Last website to learn about these topics and more. Support for Built to Last is provided by
Unico Incorporated, manufacturers of the small duct high-velocity HVAC Unico system. Unico is dedicated to the environment and has been serving residential and commercial customers around the corner and around the globe for more than 25 years.
Great Northern Lumber, providing green construction materials from skyscrapers to residential remodel. Proud to serve you for the last 27 years and into the future in the lumber industry.
Bosch, power tools for professionals. Proud sponsor of The Green Home. Florida Tile. Expect more. SPI Incorporated, protective coatings, proven performance, and real-world solutions for 24 years. Additional funding is provided by these firms.